This lesson is over biconditional statements. The objective, students will be able to write a biconditional statement and describe its truth value. Now, before I get into this, I want to make sure you realize this lesson is a little bit different than some of the other ones. I'm not going to be going over equations and solving and variables or any of that normal mathy stuff. Instead, this is more logic thinking, so there's a lot of sentences that I'm going to be writing. But instead of writing them so you can read them better, I type them up. But the thing is, I'm going to go fairly quickly through this, so you have to make sure when you get behind, pause the video and catch up. There's no way you're going to be able to go through this without pausing the video. I would have to pause it and write stuff down because I am going to go quickly through this. So a biconditional statement is a single true statement that combines a true conditional and a true converse. You join the two parts of the conditional using the phrase if and only if. So the big part of this is that if it is a true biconditional statement, it's got to be a true conditional and a true converse, and we connect those using the if and only if. Just a little FYI then, you can abbreviate if and only if by writing IFS. So this is where, again, if you're not done writing this down, you need to pause it and you need to finish writing this down and then put play so you can go, or hit play so you can go on to the next example. So writing a biconditional statement, again, the conditional and the converse both have to be true. So here's the conditional. If the sum of the measures of two angles is 180, then the two angles are supplementary. That is absolutely true. What about the converse? Remember, the converse is you take your hypothesis and you take your conclusion and you switch them. Just switch which order it goes in. So if the two angles are supplementary, then the sum of the measures of the two angles is 180. That is also true. So since those are both true, then we can write these as a biconditional. The biconditional, the sum of the measures of two angles is 180 if and only if the two angles are supplementary. So first off, make sure you don't start the biconditional with the word if. A lot of people do that because the conditional and the converse both start with if. The biconditional does not, so make sure you don't fall for that. Secondly, you can actually, if you look at this, I wrote this where it kind of mimics the conditional. It starts off with the sum of the angles is 180, sum of the angles is 180, and then it ends with the conclusion, two angles are supplementary, two angles are supplementary. So it very much mimics the conditional. You can actually do it where it mimics the converse instead, but I just always use the conditional because that way I just do it the same way every time and I don't have to be confused or try to decide which one to do. So it doesn't matter which way you do it or which way you kind of mimic, but I'm always going to mimic that conditional. So it's going to start with the sum of the angles and then end with the angles are supplementary. So for the following conditional statements, A, write a converse. B, if the converse is true, write the biconditional statement. And if the converse is false, write not reversible. So the first one, if the quadrilateral is a square, then the quadrilateral has four congruent angles. So that is true. If a quadrilateral is a square, then the quadrilateral has four congruent angles. The converse of that, if the quadrilateral has four congruent angles, then the quadrilateral is a square. Well, that's actually false, because just because it has four congruent angles doesn't mean it's a square. It could be a rectangle. A rectangle would be the counterexample for that. So since it's false, that means you cannot reverse this. It's not reversible, so it is not a biconditional. Number two, if a number is divisible by 2, then the number is even. That's true. If it's divisible by 2, it's even. So the first one, if a number is even, then it's divisible by 2. The converse, that is true. If it's divisible by 2, then it's, or sorry, if it's even, it's divisible by 2. So the biconditional, a number is divisible by 2 if and only if the number is even. And there shouldn't be two periods right there. That's not some fancy notation. That's just, I accidentally typed that wrong. Now, before we go on, I will say, let me pull up, I think I can do, so one of the ones that I changed, and it's not on your notes, but it says, if the product of two numbers is a perfect square, then the two numbers are identical. Sorry, I was going to type this up and then forgot. So if the product of two numbers is a perfect square, then the two numbers are identical. So that was the hypothesis, and that used to be on your notes, and I took it off. But I took it off because that was the conditional. So that was the conditional on our notes, but I took it off because that in itself isn't true. So we didn't have to look at the converse, and we didn't have to look at the biconditional and say it's not reversible, because the conditional itself is not true. Because if the product of two numbers is a perfect square, that doesn't mean the two numbers are reversible. The counterexample, 2 times 8 is 16. 16 is a perfect square. The square root of 16 is 4, but 2 and 8 aren't identical numbers. The converse of that would be true. If you flipped them, the converse would be true, but that conditional is not true. So again, remember, both the conditional and the converse have to be true for the biconditional to be true. So sorry that took a little bit more time. I forgot to type that up. So next thing is going backwards. So now they give us the biconditional, and I want you to write the conditional statement and the converse. So 3 points are collinear if and only if they lie on the same line. So the conditional is if 3 points are collinear, then they lie on the same line. And the converse is if 3 points lie on the same line, then they are collinear. Now again, the wording doesn't have to be exactly 100% the same, but I also will tell you, if you flip-flop those and had your conditional say this and had your converse say this, that's completely fine. You'll still get the right answer, but again, I try to make my conditional mimic my biconditional and vice versa. But since you can say it either way, it doesn't matter which way you say it for this example. A figure is a triangle if and only if it has 3 sides. So the conditional, if a figure is a triangle, then it has 3 sides. Converse, if a figure has 3 sides, then it is a triangle. Again, you could have those flip-flops. It doesn't make any difference. Now, symbolic notation. We did this at the very end of the last lesson. The notation P and then an arrow Q is read if P, then Q. They also say P implies Q, but I really like to leave it as the conditional formatting, so I'll say P, then Q a lot of times. P represents the hypothesis, and Q represents the conclusion. Now, the good thing with this is it's kind of a way to put a formula to this stuff, to put a formula to these sentences with the hypothesis and conclusion. So it's not exactly the same, but it's a kind of good way to represent that. So they give us P and Q. P is the hypothesis, Q is the conclusion. So when they say write P then Q, they're really saying write the conditional. So the conditional, if 2 lines meet at a right angle, then the 2 lines are perpendicular. Now the next one, Q comes first, then P. Well, if it's that way, just flip-flopped, flip the hypothesis and conclusion, so that's the converse. If the 2 lines are perpendicular, then the 2 lines meet at a right angle. So the way they represent a biconditional is if P points at Q and Q points at P, they kind of point at each other, and so they just write the arrow with 2 arrows pointing at each other, with 2 little triangles that point at each other. So obviously that's P if and only if Q. That's how you'd say that. So now they give us P and Q, and they want it 3 ways. The first way is the conditional way, where P then Q. Second is where you flip those, Q then P, and then 3 is the biconditional. So number 1, if 2 angles have the same measure, then they are congruent. 2, if 2 angles are congruent, then they have the same measure. And 3, remember, don't start the word if. And for this one, I definitely would start with the 2 angles have the same measure, because that's the P part. So 2 angles have the same measure if and only if they are congruent. Now the next one, if you don't like to write these symbols, you can also write out the words. So that says angle A is a right angle, and then Q is the measure of angle A is 90 degrees. So the conditional, if angle A is a right angle, then measurement of angle A is 90 degrees. The converse, if measurement of angle A is 90 degrees, then A is a right angle. And the biconditional, angle A is a right angle if and only if the measure of angle A is 90. But again, this is one of those things that you need to make sure you remember and memorize how this notation works, because these really aren't that hard. It's almost like substitution. You substitute this phrase in for P, this phrase in for Q, and you just have to remember your if and then for that. Obviously, for biconditionals, it's a little bit more difficult. You just need to remember the if and only if. But again, so far, this is all memorization stuff. So make sure you study that. If you have any questions, make sure you let me know. And again, I was obviously going too quickly, so make sure you're going through and pausing that. If you fell really far behind, go back and redo that, please.